These are the examples for Algebra 2B, Credit 3, Lesson 17.1. Lesson 17.1, we're going to introduce a new way of measuring angles called radians. You already know about degrees. When we measure an angle in degrees, for example, a right angle, remember, is 90 degrees. Anything less than that would be something less. For example, this here might be an angle of about 60 degrees. And of course, we also learned at some point in the past that if we have a straight angle or a straight line, that measures 180 degrees. So we're hopefully somewhat familiar with degrees. So what is a radian? And so we're going to go into a brief description of what a radian is, and then we're going to talk about doing some conversions between degrees and radians and degrees. All right, so let's take a look at, first of all, what is a radian? So let's say we have a circle with a radius r. And we have, let's make an angle here. Of course, that's also a radius. And we have this arc here, which we're going to call S. And this angle here that's created, we'll call theta. Remember, the Greek letters are often used to name angles. So we have this angle theta, and it's formed by these two sides, which are both radiuses of the circle. So theta in radians, now we can measure that in degrees still, but in radians, it's defined as the arc length, which remember is S, divided by the radius. Now, here's where it starts to get kind of interesting, and we'll just do a quick intro, and then we'll jump into the examples. If the arc length is equal to the radius, we have r divided by r, we would say that theta has a measure of 1 radian. Because remember, that angle, or that angle in radians is defined by the arc length, the ratio of the arc length to the radius. Now, one other fun fact too, 1 radian, that's about 1 radian there, because you can see the radius and the arc length are the same there. Fun fact, that's about, let's put it over here actually, it's about 57.3 degrees. So if you kind of wanted a conversion or a rough estimate. Now, another fun fact with radians, and let's mention this and we'll jump into the examples. So once again, let's put up our ratio. It's the arc length divided by the radius. And let's say that the arc length, the angle is the entire circumference of the circle. Well, we know that the circumference of the circle is found by the formula 2 pi r. So that would be the circumference, the distance around the circle, and then divided by the radius. Now these cancel, and we see that an entire circle, all the way around the circle, which we know is 360 degrees, would be 2 pi radians. So 2 pi radians is equal to 360 degrees. And we have that ratio that 2 pi, we can write it as 2 pi over 360, because if these are the same, this is equal to 1. And so we can reduce this. These are both even numbers. We can divide by 2, and we get pi over 180. And that's important because that's the conversion that we're going to use when we're converting from degrees into radians. We're going to multiply by pi over 180. And interestingly enough, on the last two problems, we're going from radians back to degrees. We just flip this and we'll multiply by 180 over pi. So that's a little intro into what a radian is. And now let's go ahead and jump into the examples here. So our example for number 1, we have the directions are to convert the measure from degrees to radians, and we're going to leave our answer in terms of pi. In other words, we're not going to substitute 3.14 in for pi and get a number, which you could, but we'll just leave it in terms of pi. All right, so our first example, we have 120 degrees. So remember, we just said that we're going to multiply by that conversion factor of pi over 180. And so we make the 120 a fraction. We can make any whole number a fraction by putting it over 1. And remember how we multiply fractions, numerator times numerator. So we have 120 pi denominator times denominator, 1 times 180 is 180. Now, that is our answer in radians. However, we always want to see if we can simplify our answer here. Some hints on simplifying. So the work that you're going to be doing, if the numbers end in a 5, if it ends in a 5, we're going to divide by 45. So again, that's the whole process of finding the greatest common factor or the largest number that we can divide into both those. We don't have that here. The rule we're going to use, though, if it ends in a 0, it's either going to be 30 or 60. So we'll start with 60, and if 60 doesn't go into both these numbers, then we'll be using 30. So we divide 120 by 60, and we get 2. So we have 2 pi, and 180 divided by 60, that also divides out evenly. 180 divided by 60 is 3. So our answer is 2 pi over 3 radians. And the question, do you have to write the word radians? Yes, you do. Just like when we measure an angle in degrees, we put the degree symbol there. So when it's in radians, we write the word radians after it to indicate that that is an angle measure in radians. All right, our next example, we have a negative angle. It's not going to change too much what we do, except our answer will be negative. So let's go ahead and do that. So we have negative 225 over 1 times, remember our conversion factor, pi over 180. So we multiply the numerators. Negative 225 times pi is negative 225 pi. 1 times 180 is 180, multiplying the denominators. Now, remember we said that if the, well, I think I said numerator, but I'll say it now. If the numerator ends, and that's what we're looking at, in a 5, then we will just divide by 45. Now, is that always the case? No, but in these problems, we're giving you that little hint or that help that if it ends in a 5, you can just divide by 45. And so let's go ahead and do that. We have negative 225 divided by 45, and that would be negative 5. So we have negative, don't forget the pi. And then 180 divided by 45 is 4. So we have negative 5 pi over 4 radians. And so that's our answer for an example for number 2. All right, moving on into the last 2 problems. So in the last 2, we're going the other way, if you will. And what we mean by that is instead of converting from degrees into radians, we have a measurement in radians. Now, I know you might be thinking, well, you don't write the word radians there, but we're going to be, well, maybe we should. Let's actually do that. Let's not make that argument. So let's go ahead and write that. Because the directions do say convert the measure from radians to degrees. So it's given that this is in radians, but let's go ahead and write that there to be consistent with what we said earlier. All right, so we have 7 pi over 4. And so we're going to use a similar conversion factor. Remember we said in the intro is that when we're going from radians to degrees, we're just going to flip that. Because remember, we said 2 pi over 360 is equal to 1. And we just simplify that to pi over 180, which is also equal to 1 in terms of the angle measures in degrees. So that's why we can flip that. So 180 over pi. All right. So, and to be clear, it shouldn't say equal to 1, but they mean the same thing. So let's kind of just emphasize that. So 2 pi, an angle of 2 pi radians and 360 degrees is the same. And of course, we just simplify that to pi over 180, and that's the same as well. Pi radians and 180 degrees. All right, so let's go ahead and multiply here. 7 times 180 is 1,260 pi. 4 times pi is 4 pi. Make this look a little bit nicer. All right, so now, of course, we're going from radians to degrees, so we would expect the pi symbol to cancel out, and it does. And then 120 divided by 4 gives us 315. And of course, that's now in degrees, so we put the degree symbol. All right, so one more example here. We're going to go one more time, converting from radians to degrees. And so we have negative 5 pi over 3. And remember, when it's radians to degrees, our conversion factor is 180 over pi. So, and remember, over here it was pi over 180. So 180 over pi, when we're going from radians to degrees. All right, so we multiply our numerators, negative 5 pi times 180, and that gives us negative 900 pi. 3 times pi is 3 pi. And again, what's always going to happen in the work you're going to be doing when we're converting from radians to degrees is the pi's will cancel. And then negative 900 divided by 3 gives us negative 300. And so, in case you're wondering, in your work, that will happen as well, too. These numbers will divide out evenly. All right, so that is it for the examples for lesson 17.1. So as always, pause, rewind the videos, and let's go ahead and we're moving this over here just a little bit so we can hopefully, in case you want to pause and look at all 4 of those examples. All right, so that's it for lesson 17.1. Good luck with the work. And until the next video, take care and God bless.